Hello everyone. Welcome back to the channel and the ML series. This is the rebooting of the ML series after so many of the requests. So let's start this with a very small topic. Previously, we have learned the normal equation, and now we are going to learn about what is the computational complexity. That when you are using some methods like normal equation or there is one more method that is called the SVD approach. Okay, singular value decomposition. We have talked earlier. So there is somewhat computational time. So we'll be understand that how the computational time affect the efficiency and which one is better and what is the alternatives. So first of all, subscribe this channel, hit this subscribe button, like this, and share with the people who are really interested to learn AI and machine learning. Let's start this. Okay, so this is the document for you. I'm just going to share in the link below where you can just uh, see this. Okay, first I'm going to share you. I hope it is visible. Okay, is that fine right now? I think. Okay, yeah, that's fine right now. Okay, so there are two main methods we have right now. That is one is the normal, one is the SVD. So in the normal equation, what it does that it takes the inverse of the matrix. Okay. So in the inverting a matrix, there is a time complexity. Okay. So time complexity is n to the power 2.4 to n to the power 3. So it's like that if you double the number of features, the computational time will be increased by approximately 5.3 times or to 8 times. So this is huge. If you just double the number of features, then the computational complexity is increasing a lot, and that is not good, guys. Because in the performance, it can handle the small and medium sized data set, but struggle with the data which is very large, like 100,000 data sets. Okay, then what is the SVD approach? Like in the SVD, there is a it is more faster than the normal equation, but there is a still the cost, it is n square. Okay, so that is also the huge cost. Okay, uh, that's why we need some better approach. We'll be seeing that what is going to be the better approach in the next video. It is going to be very short video. So both of the normal equation and SVD become slow and memory intensive when the number of feature is very large and training data doesn't fit into the memory. So like if you are using um, normal equation or SVD, then your system will be crashed due to the memory. Okay, so doing computation for the same thing in a different way, in a more efficient way, is always the key to save your memory, your computational energy, and your time as well. Okay, so in such of the cases, we are going to use the gradient descent, and that is stochastic gradient descent. We'll be seeing these two main things go into the in depth, and we'll be seeing in the next video. This was very short video and also the reboot video. So I hope that you got the point, and thank you so much, guys. I'll meet you in the next video with the proper solid theoretical parts, and we'll be also doing some practical as well, because practical is the most important and it is the thrilling experience. So, thank you so much, guys. See you in the next video. Bye bye. Take care.